session of SummerSOC. My name is Holger Schwarz, and you won't regret being here. We have two distinguished speakers. This morning we'll start with Willem-Jan van Heuvel from Tilburg University and the JADS Academy of Data Science, well-known speaker at SummerSOC. So just keep the introduction short, and the stage is yours.
Hey, Holger. So thank you very much for the brief introduction. Great to see so many of you here. Great to see that after all these years of SummerSOC, you still like to listen to my talks. And for those of you who are not familiar with where I come from, I decided, like the other speakers, also to give you a brief introduction from this little place, this little home from where I am. So I'm located in the Netherlands. I guess I'm one of the few ones representing the Netherlands, the Dutch. And I'm responsible for setting up this new institute, which is called JADS, Jheronimus Academy of Data Science. And we are now a few years underway. And over these past years, what we have been doing is not only setting up great new educational programs for students, PhD students, also professionals, but at the same time we also started to do some work. And we started to begin from scratch, which means that our educational offerings, which in fact are delivered by two universities, which makes it quite unique, at least two universities that are living together so close. It's Tilburg University, a university that does research, education, and social science, and the Technical University of Eindhoven, who you may better know yourself. You may have collaborated with in the past, people like Wilton used to work there, and it's a technical university revolving all around engineering. So what we try to do with JADS is we try to bring the best of two breeds, the social sciences with the engineering. And over the past years, we started this journey. We started from scratch, new courses, new programs, and also what we try to do, and I emphasize on try, is we try to adopt a new paradigm to conduct research and to do education. And this little journey over the past year, I want to share with you. So what I will not do today, just to be very concrete and specific, and by the way, this is a very picturesque picture of our campus. I'm still proud of it. Sorry, excuse me for that. So what I try to do today is I'll try to have a little bit of fun with you. I think it's very important to have fun here at the summer school. But what I will not do is I will not present very dull research results. In fact, we don't have that many yet. Remember, we just started. I just started my team for about 1 year ago. Martin Gareka is also here joining me this year. And in fact, we are now also simultaneously doing a Raban workshop in the next room. So Raban is one of these new H720 projects on serverless computing that we have been involved in JADS. So what I want to have with you this morning is to have a little bit of fun. I hope to get inspired also by you guys, to the extent possible, of course, so early in the morning. And I want to share some initial, some core research results, because yes, we do have some results to share with you. And I want to extend the network and invite you, in fact, to the network. So do already a little bit of spoilers, advertisement, I guess, at the beginning of this talk. We have currently 12 vacancies open, 12 to 15, purely for assistant professor plus level. So if any of you knows someone who's interested to come and work and live in the Netherlands and have a lot of fun and do cool research, you're invited to inform these people. So what can you expect from us today, this morning? And I'll try to stick to the time. By the way, sometimes I'm getting very enthusiastic about the topic and start to be a machine gun and start to talk too quickly. Just slow me down. And in case you have questions, just ask them. And I will try to answer them to the extent possible. So I'm a professor. So what we try to do for you today is we try to start today from the opposite side that you're used to, because unfortunately, I could only join in the summer school a bit later this year because I had a lot of obligations back home. But having said that, what I tasted from the presentations is that many of those do not really start from the application, because we have chosen to really start from the application, from the grassroots of the problem, and then see what evolves.
I disagree. I gave 3 slides for the Einstein Center Digital Future, and that's where we also start from.
That's very good, yes.
But okay, I shouldn't say fully, but we'll see.
Yes, okay, very good. It's good we have a discussion, but and I didn't, unfortunately, yes, I asked for it. So, but of course I didn't attend your presentation, so that's good. But okay, so what we try to do is we try to start from the application, doing things without a problem in mind. So we don't know yet what the problem is. We have absolutely no idea. We just do it because we think it provides fertile grounds, let's say, stating research problems and new cool research. And of course, what we also have is we have some projects really starting from the technology. So without having, let's say, the application domain too much in mind, we have the projects like Radon that Martin will say a little bit about more toward the end of today's presentation. So what's the idea? So our idea is learning by doing. So, and it's learning by doing. It may sound old, but in fact, it is quite hard to really get it implemented. We try to do it in our education program. I'll say a little bit more about how we try to do it, but you may wonder why. So what's the benefit of doing it? So one of the ideas that we are trying to adopt back home at JADS is that we're trying to pick up some of the methods and methodologies from industry, which sometimes are in fact quite successful. So if you look at companies like the Googles, the Amazons, and the Netflix of this world, do not any longer resort to only a couple of experiments per year, like 10, 15 years ago. You would only do a little bit of experimentation. If you look at today's modern and successful companies, you see that they do a couple of thousand, up to 10,000 experiments a year, okay? Which really means a lot for the underpinning ICT infrastructure and the way in which you organize stuff. So that's also what we try to adopt. So what we want to do in our research is we want to adopt this paradigm of, let's say, massive experimentation and frequent experimentation. So what's the element of our approach that we decided to do is we decided to have a multidisciplinary approach. I will say a little bit more about it later on, because it's simple to say, I mean, everyone does do a multidisciplinary approach, but at the end of the day, to do it effectively, it demands, we believe, a certain setup of the way in which you organize your institute.
Willem-Jan, may I infer from the first bullet that you also have philosophers on campus?
We have people with ethical background, yes. Yeah, from ethics.
Not only computer science?
No. So what we try to do is we try to work very closely together with industry. Again, so we make things and very quickly. So we do prototyping very quickly. Then we experiment in the field or in a living lab, which are two different aspects. We are, in some cases, treated as the same. And then we try to learn. And this learning does not only pertain to our students, who also have to do this, but also to ourselves and to our PhDs. So what we're trying to do, I'm not saying we're succeeding, but we're trying to introduce much more short-cycled research in this way. And students really have to start from the beginning with a prototype, with an idea, test it out, and test the waters. So what we're trying to do is then also to generalize. So once we have found, let's say, a solution for specific problems, we try to generalize them so they also apply to other domains. And we try to do this in close connection with industry. So one of the characteristics of this little campus that we're trying to set up, but which will be extended, I just heard yesterday with another building, is we are very closely working together with industry, and they are sitting within the building. And that's really different. I mean, also back home in the Tilburg campus or other campuses where I've worked, of course, there's a lot of industry in the periphery, which is also true for your own institute, I know for sure. But it really also makes a difference if the people are in the periphery of the campus or really living with you. You're eating with them, you're having lunch with them, sometimes dinner, you have joint presentations, joint research seminars. So this is what we're trying to do. So we have people from computer science, IT, we have people sitting there from analytics, so people with a mathematical background, AI, but also people which come from a domain, like criminology. We also have people from law and from ethics there. And this is exceedingly important once you try things out in practice. And I will share with you some of our recent experiences on that. My statement would be very bluntly, if you don't take that into account, any solution you would present is very prone to fail effectively when you try to implement it. So we think and we do, and we try to do this by mainly conducting field experiments and living labs, and try to work with the end user as closely together. And we try to do this physically. So it's not only that you say you're working very closely together, you pick up requirements, you draw use case diagrams, which is all fine. You do it together, you sit in the same room, and you discuss and talk about it and share ideas. So we have a couple of projects that we would like to share with you today, and it's three projects in particular. It's a ANITA project, which revolves around the application of data science to detect crime on the internet. So as you may know, crime is getting more and more on the internet, on the dark net. And another one is Visor. Visor is a Dutch national project that I've just started with grateful funding from the Dutch police and some municipalities. And this is really about how we can increase safety during events, like music festivals, which is pretty cool. So we went out to the festival. We did do it. So I will show you later on what the results were. It was very cool, very exciting, and I learned a lot. Of course, we have some startups. I only mentioned here two, Pandora and HITS. And Pandora is a company which is now quite successful, and it's a spin-off effect from the smaller. There's many more I should say, but like Pushbirds, which is very successful. So this is a way in which we like to. This is our play in the field that we like to work in. I've said already a lot on this. So I guess I can.
Why do you call it crime room?
Crime, because we conduct crime there ourselves. No. Very catchy name. We could attract extra funding. It's very simple.
But this has nothing to do with the crime project.
Yeah, it has. Yes. So what I did do is we freed up a little room. We call it the crime room. That was for us a starting point. We put in police officers. We put in people from municipalities. We put in techs. We put in some of our researchers, and that was the burning place for some of these projects. This is how we worked thus far. So this action, I would like to emphasize, this is part of our curriculum. So we have this historic master program between the two universities, and there's a lot of diagrams there that you can read. This is data on permission in action. So here the students have to set up a company. So they have to set up a venture, and they have to fail. We hope they fail, in fact, because they learn from it. So, what we do in our program, which makes it maybe interesting for you guys, is that we don't only have cognitive learning objectives, but at the same time, we also have a lot of mentoring and coaching. So we do have individual coaches, which makes also a very expensive program, probably. And we have a mentor program. And these mentors are guys with a track record in finance, in marketing, in attracting venture capital, in law, all that stuff. And these are people from industry who have been affiliated to us. So in terms of the coaching, what we do is we don't only resort to the old-fashioned, nothing wrong with it, by the way, skills like academic writing or presentation, so maybe I could still even use it myself sometimes. But we also have other coaching programs in place, like, for example, negotiation, how you do it, how do you convince people. So these are all skills which you also need at the end of the day to be successful, what we would call data entrepreneur. Because this is not a pure, you may see it yourself, data science program. It's really all about data entrepreneurship and very multidisciplinary in nature. And one of the new things which we did, which I think very cool, and I put it in for Bernard. So is we also introduced the minor, for example, one of smart industry. And we are doing it together with industry. So the industry is sponsoring it, also heavy duty, and also providing cases and the data, which is interesting. And again, it's all about action, but getting in action mode. So what I want to do now is I'm going to take a chunk of time, I don't know how long, I guess 20-25 minutes, to talk a little bit about crime and the project we have been doing. So if you look in the Netherlands, we are a very small country, but very big in drug production, as you may know. So we are the world's largest ecstasy producer. And a lot of this, it means a lot of import effect of the materials we need to produce synthetic drugs, and also a lot of export. We import a lot from Australia and China, through Rotterdam, through Antwerp, for example, and then we export it back to Australia and some stuff in China and all throughout Europe, which in fact a very
good business.
impressive logistic effort. In that respect, I respect it. But even let's take a very small city like Tilburg. It's nothing. It's like 500,000. So we have a gross revenue of about 900 million a year only in marijuana production and logistics. And that makes it by far the largest economic activity.
Growth per year.
Yes.
No,
No, revenue.
Revenue.
Yes, money involved. So it's a lot. So it has a huge impact. So this is one of the reasons we have picked it up. So we're trying to pick up high relevant topics which have a lot of relevance to society and which also I can find funding for, to be honest.
But unfortunately, they don't pay tax.
They don't pay tax. No, but the taxpayer
Not yet.
doesn't like it. So it also gets sort of subversive. So it's organized crime. It's very well organized crime. We shouldn't underestimate it. In fact, at some point in time, we start to respect it for it. But it's also very much subversive, which means the legal world, and the illegal world, they get interwoven. So it's not only the banks who are involved, or the notaries, but also the carpenters, the people who are responsible for the electrics, the gardeners even. So everyone somehow is part of this ecosystem, which makes it tricky. So what you need to find is ways to expose them, in ways to reveal this crime and get a better insight. So that's of course, one of our objectives is through data, trying to get a better insight. And it gets more and more digital. So you may have heard that the Dutch police is quite active to stop electronic markets in the darknet, for example. But we are selling and buying, in fact, more and more drugs, but also weapons. And human trafficking is done through the darknet, and it's growing quite explosively. So that's why we have chosen this topic. So I just want to explain to you the reason why we have particularly chosen these areas. So it's important, local perspective, national perspective, European one as well, but also it has very interesting ramifications on the research side. So it's not only purely applied. At the end of the day, we are interested to publish, to do research. So, and in particular, what we would like to do by exploiting data science is to improve insight, to reveal, let's say, these now hidden networks, criminal networks. We also want, at the end of the day, to predict criminal activities, which I can tell you is quite difficult. So, just as an anecdotal story, we have done several hackathons together with full-day hackathons with the Dutch police, with municipalities like the Bosch and Tilburg and Heuvel, which are all in the southern part of the Netherlands. And we try to predict where they would grow marijuana. So you can look at the consumption of electricity, you can look at the consumption of water, you can look at companies. Some of you have 10 companies on one street address. You can look at previous patterns, and this is what we have done. So we have done it together in a group of about 50 police officers, tax authority people from the water and utility companies, and you name it. Yes, you would have some of the technologies in place. Many of them, by the way, use static data only. But I think that one of the main issues there is to interpret the data. So, for example,
so it's not privacy, as Chris would say.
I mean, yes, I will come back on the privacy later on, because the privacy...
I have given up already in this community.
Yes.
No, I mean, what you say,
that's
is
the
It's anti-privacy.
I know.
We are, of course, always struggling with the privacy element, and I will get back on that, because we had some ideas in mind with another project, and they all failed because of GDPR. Anyway, in this case, we didn't fail. We did do some of the experiments with open data. Yes, indeed, with the open data, we could point to what people, which was wrong. Yes, even after GDPR officers checked the data for privacy, let's say, violations, we still could, through cross-correlation, find some very private data. But for example, one of the things we found is that there was a lot of drug activities in some areas in one of the cities, Tilburg, by the way, where the ratio female-male was higher. So there was a correlation they found between the ratio of female males and the number of drug production places. And then we thought this is strange, because you would think it's mainly done by males, so maybe there's something wrong there. But then there was a police officer from the area, and he said, listen, this is a place where you have a lot of houses where elderly people live. And guess what? There's many more females than males. Anyway, just a short anecdote, the fun we go through. And at the highest level, of course, we want to prevent. So at the end of the day, we are aware of the dark side of stuff, and we do appreciate that. Yes, we do work with GDPR officers. Before we do any experiment, we have to go through an ethical and legal board who tries to test the water as good as possible, but typically they do a check up front and never afterwards, which is okay, something which is maybe for them a lesson learned. So trying to combine.
What does it mean? The check afterwards is look at the result and then figure
Yeah, so one of the things is that the data, you have to remove it after a couple of months. Yeah, it's very hard to check, of course, right? So, for example, in one of my experiments, I had students gathering data, mobile phones, drones flying. I had smart glasses. And of course, the data is scattered all over the place. And whilst I informed people participating in the experiment, they would have to remove the data, I would have to believe them on blue eyes. There's no, so it's tricky. It's not an easy topic. And I'm not an expert in any way. But I do recognize it is extremely important to take into account. Okay, this is ANITA, which in fact was, I guess, announced as the main topic. I'm sorry, I apologize. I'm deviating a little bit. So it's on online and offline trafficking. It's an EU Action 20 project that started about 4 months ago. And it's a typical project that's done very closely affiliated with police organizations. And one of the underlying objectives is that we learn these LEAs, these law enforcement agencies, sorry for the to exploit data science, to exploit data better than before. So we are considering both the open web, which they call open source data, as well as closed or deep source data, and we do this by crawling the web, cross-correlating. Yes, we hit our privacy issues there.
And you can call it darknet?
Yes. Yes. Yeah. So we use that torrents, for example, to access it. Yeah. Yeah. And VPNs, etc. So what we have been doing thus far, just to give you an idea, is we have been done a great study. So we have done a literature review. We have been, in particular, been interested in risk assessments. So we want to assess the risk that a particular site is involved into criminal activities. We want to come up with a, let's say, thermometer that you can put into the website, and you can very quickly decide, based on these measurements that you make, this assessment that you do, whether or not it may involve criminal behavior. And we want to then suggest countermeasures, so proven practices. So we have done a research review where we have identified various risk levels, various types of criminal activity that we are considering, like, for example, weapons, human trafficking, drugs. It's not all the nice stories. So sometimes from an ethical perspective, I'm not touching some topics myself because I really don't want to touch them at all. And we take into account risk level parameters, website appearance parameters, which are parameters that give an indication whether or not a website is in fact criminal. And we also have quality parameters identified.
Give 1 or 2 examples how you detected website is criminal.
Pardon me, how you?
Can you give 1 or 2 examples how you detected the website is criminal? Of course, if they indicate I sell weapons, it's clear.
Yes.
Is it so simple? No.
No, yeah, I mean, what we have done thus far is simply we came up with the responsiveness of websites. If there is a very similar website, a lot of them very similar, but only small deviations, then it is an indicator that it may be criminal. And to try to fake the review. We have done also topic modeling analysis. I'm going to skip through this very quickly. I think it's boring. And we came to the conclusion that there is a gap in scientific studies on anonymous crawling policies. So can you crawl a website without someone knowing that you have done it, for example, and some other stuff that will delve deeper into later into the project when we start to develop a tool together with the police to, let's say, come up with this risk assessment. Visor Project 2, which I think is a little bit more interesting and more lively, and it better represents what we want to do. So what we have been doing is we have been starting some quite fun research on smart events, and in particular I got quite interested in festivals myself. I like to go to festivals myself, by the way, but it's also this growing market. And it's quite interesting because these festivals are like microcosmic cities in their own right. So they are being built up like this, a few days, they exist for a couple of days, maybe a week, and then they disappear. And they come with their own ethical norms, with their own, not own legal system, but at least within, let's say, festival terrain, you have your own norms, what's allowed and what's not. And of course, it brings a lot of security threats. I'm not only talking about the terrorist threats or something, but also all types of other threats, like pickpocketing, like drought, for example, like diseases, you name it. So, this market is booming, and if you look at the Netherlands only, for those of you who can read this very well, in the evening you can get a beer from me. It's in Dutch, but in the Netherlands we have about 850 festivals a year, and we attract about 90 million visitors. So it's a big thing. It has a lot of impact, and we like impact. So then we started to look, and this started at the beginning of this year. So it's very recent work. So we started this at the beginning of this year, and we started not only by delving into the top, but also getting the money to do stuff, because we didn't have any. So we started to look a little bit at smart event technologies. Yes, there's a lot of sentiment analysis, for example, ongoing during the festival. Also, festivals are exploiting data themselves. For example, to compose the next year's program, they look at social media. So they look at the profiles of previous visitors. And that way they compose it. Crowd control through GPS data, risk analysis, augmented reality. We also believe, I mean, with the Google Glasses, Generation 1 clearly was not a big success, but I still think it is way to go. I still think it's the future. And AI is also really picking up very quickly and getting more and more mature. So it's also, for me, also in the field of data and circuit engineering, a more and more interesting topic. I mean, in the good old days when I was still playing with my Atari and doing studies myself, we also had GPUs, but they were by far not powerful enough. Now suddenly we can do cool stuff. So what did we do? So we started at the beginning of this year to talk to the Dutch police and some festivals and municipalities and security organizations. And what we wanted to do is come up with and we came up with this idea. So the idea is to prepare, let's say, some data before the festival would start. So what we wanted to do is profiling of people, and then, for example, cluster all people who have an interest in line dancing. I'm saying something silly now, because of course in the context of security, you can use it in another way. And then during the festival, the idea is that we would use dynamic streaming data, not only textual data from social media, but also visual data. So this is really new terrain for us. So we wanted to cross-correlate also visual data, not only data from cameras on the terrain, but also from drones, for example, and smart glasses. So we started to experiment with that, without yet having in mind that much what the actual research problems were, right? Because I want to stress, no idea whatsoever, but we like it. It's cool, it's fun, and for me it's also a way to attract students, to be very honest, not only into the program, but also into the research, in learning throughout when they are involved in events like this. And at the end of the day, we wanted to learn and disseminate. So what would it look like? The idea was we would extract data from the Facebooks of this world, regulate it, profile it, and safely store it. That would be the prepare and profile phase. To be very honest, we didn't do this at all. My privacy officer blocked it. So I had discussions with the team of privacy officers at the Tilburg and Heuvel University just even before the week of the actual start of the festival and said, you cannot do this. So they stopped. So at the end of the day, in the project, I resorted to, in fact, some experiments during the event itself. So we went to we chose fast pop. Why did we choose fast pop? We are very optimistic. In this region, I could find money, quite a lot of money, in fact, to get things kick-started. So, and we collected some security and safety data from the law enforcement officers, fire brigades, emergency medical services, the organizer, and the municipalities. And what we decided to do is to check on a couple of phenomena. They themselves were very much interested in pickpocketing to predict fightings, for example, or identify them quicker than before. Also prevent sexual harassment, which is really a very big problem during these festivals, unfortunately. Heat and cold, same, etc., etc. And at the end of the day, we're also very much interested in the crowd control in this particular case because they had a new logistical plan and they wanted to test it and see it in action and learn from it with data. So we decided we could also help them with that. So for us, what made it also very interesting is this festival takes place in April. So we had done these experiments in April, and it's can be quite cold. This year was extremely warm. It was the same temperature as here right now. But normally it's quite cold, very rainy, and but all the concerts take place in tents, which means it's dark, which means it's not only a lot of people dancing and moving, but also light effects that directly impact you, which makes the identification of people or groups of people even more difficult. So that we thought that could be a fertile grounds for us to do future research. So, so a little bit more about this event. It's about 15 stages, 175 bands. It's about 50,000 people, I believe, each day coming in, 20,000 people staying at the camping, 30,000 people coming out. So, and this is how it looks like. This is one of the drone pictures we in fact produced. So, what you see here is one of the tents. It's a big one. It's called the Apollo tent. It can hold about 18,000 people. It can also host a big bowling plane. So it's a big thing. So it's bigger than Ziggo, which is in Amsterdam. And first, it's one of the tokens of the let's say concert halls that we have. And from a technical perspective, we thought, yes, these experiments are interesting. So we convinced also the police and municipalities and our universities. But also, what we wanted to do is stretch the legal boundaries, what we are allowed to do, and I promised them to go over them. And also the ethical considerations. So again, we wanted to use data to help security, to increase security. The security is safeguarded by private companies at the festival terrain. The police, in principle, may not come in. So normally what happens is that if there is any violation that the security companies think is severe enough, they are handed over to the Dutch police. In practice, luckily, police works very closely together with these private companies. And from a technical perspective, we were using video, a lot of video. We were using 3 drones. We were using also cameras, about 20+ cameras, fixed cameras on the terrain with a very quality. So you also have to deal with that. And at the same time, also what we bought is smart glasses, Fuzzi's smart glasses, which turned out to be the best ones because they had the most. They didn't look very nice, to be very honest, but they had most processing capacity, which we needed at the end of the day. So from a technical perspective, but from an ethical perspective, what they wanted to do for us, for example, is also look at slide the drones over the camping and do checks there. And I said from an ethical perspective, I'm not going to participate in those experiments. For me, it's out of my league. I mean, these kids, they do whatever they do at the camping site. That goes beyond what I wanted. So in fact, what we did have, we had a little place here at Passport. We had a container. It was a shock for me. So I guess that being a professor in the Netherlands is different than being a professor in some other parts in Europe. But I'm still amused if I set up a laboratory. At least there's chairs and tables and some facilities. There was nothing there. So it's quite an experience for us, in fact, to get everything organized. This is how the container looked like, just for your information, very poor. This is all the glasses that we had been using that were was strong enough. And I want to show you a little video that makes it a little bit more lively with the stuff we have been doing. It's a little bit of a promo video. So, let me find it. Okay, I'm not sure if the audio may be a problem.
So all is here. So we could get it here.
What's the problem now? There is no audio now.
Hoe zit die?
Ah,
Wel.
ah. Festival. Ja, nee.
It's good, it's okay.
My name is Willem-Jan Heuvel.
Yeah, sorry for that.
Professor of Data Engineering and Director of Studies at JADS. And JADS is a collaboration between Tilburg University and Technical University of Eindhoven. So currently we are at the possible premises where we are currently conducting various very exciting experiments revolving around the application of data science for improving safety at small events.
We werden heel vaak mee aan het experiment. Vooral omdat we zelf medewijzen omdat we het leuk vinden om te faciliteren. Maar dat is echt het eerste experiment. Maar als iets uitkomt waar plaats van een voordeel bij heeft in de brandcontrole, dan maken we dat aan.
Wij hebben een hartstikke mooi evenement. Er gebeurt hier zo ontzettend veel. Het proeftuin zijn voor heel veel experimenten.
These are the security ones, right?
Yes, yeah, the festival organization. Yes. So these are our students. So what we wanted to do is,
What we're trying to do is we're trying to exploit all types of data, so video data stemming from drones, for example, and also smart glasses. We're collecting all this data to improve the safety so people can really enjoy, let's say, the festival much better and don't need to bother too much about safety at the event.
Als stichting natuurlijk aan testmoment over praten, willen we eigenlijk zorgen dat naar de toekomst op basis van innovaties, van nieuwe technieken, dat het mogelijk is om weer om daarmee de veiligheid in de algemeenheid te geven.
Yes, something is you can identify people. People who are misbehaving or causing some school or immoral behavior. But also triangulate detection using multiple devices, multiple equipments, right? So we have 3 drones flying, we have 3 smart glasses, 3 smartphones. What we want to do is track GPS trajectories, but also triangulate with overwatch sentry cameras from drones and track visual trajectories from the smart glasses.
So these are using smart glasses. It's basically just the camera which automatically captures images. So right now I'm looking at you, but also I'm capturing images of you.
Waar ik hoop is dat we mensen kunnen vangen met middelen. En dat slimme middelen inzetten en ervoor zorgen dat we minder fietsmiddelen nodig hebben om zelf ook nog beter weg te kunnen weten. En zeker te detecten waar we nu tegenaan lopen en waar we begrip op krijgen.
Als beveiligingsorganisatie zien we dat het opschat dat we hun eigenlijk aan het experimenteren zijn met bepaalde gebruiken.
Students like to work in this project because on the one hand side, they are in a fun environment, but at the same time they can learn. And that's our adagum, it is learning by doing. So by being in action, we learn.
Jheronimus data science. Science happening.
I thought it was fun. It is marketing, yes.
Yeah, no, I really think it's fantastic. And did you actually detect a lot of crime?
No.
No.
We didn't detect all that stuff. No, what we did do is we couldn't in fact detect because we're not allowed. What we could detect is anomalous behavior, which we did. What we did, for example, is we found patterns like zigzagging, in zigzagging, both left and right, which can indicate potential pickpocketers. But we couldn't do it too much. We also did a check on trajectories. We found also outliers. We did do it through clustering, etc., etc. But we are still, in fact, processing the data, because one of the crazy ideas which we had is to prevent privacy issues by looking at strange group behavior. For example, detecting group fighting, and group fighting is mimicked during festivals in mosh pits, which some of you may know. These kids, they run with very hard music, they run around, it's like a whirlwind, which can cause injury, etc. We want to predict it, we want to train algorithms to do it. Of course, you need to have enough video material. So in many cases, what you only could do is collect the material at the end of the day to train the algorithms. I'm going to skip now a lot. I could have told a little bit more about the actual results, but I want to do the random stuff as well. All right. So we did have some results in the trajectories. We did have a couple of photographs. We also have identification. What I was not allowed to do is identify people. So I even volunteers. I was not allowed to do it. But at the end of the day, what we could do is identification of t-shirts. This is why I came up with the t-shirt idea. So in theory, we can do much more, but in practice, we were really. Yeah, that's it.
Okay, thanks, Willem-Jan. I was also participating there in the PASPOP event. I'd like to say that it's also interesting from the point of view of the students. There was this kind of hackathon effect in which we were all together for 3 days with our computer, the glasses, the people there, so we were encouraged actually to work on it. Maybe on a lab in the university, things go, I don't know, slower, tend to procrastinate or tend to take longer. But being there, the adrenaline, the fact that we had to go out and gather the data, the fact that we had to go out and interact with the people and to show what we were doing was actually encouraging myself and the students and Willem-Jan as well to perform, to get a little bit more. So I think that it's interesting in that sense as well. I have to say that I'm not actually involved in that project, but I was happy to go to PASPOP and try to help from the early evening till the late evening, and then at night just go to the concerts with some bands, do some pickpocketing and mosh pitting and everything. Now I will switch slightly the topic here, because we are going to talk about another project we are running this round, in which basically we take this bottom-up, more traditional approach, in the sense that we were doing this top-down approach from the VR project, so gathering the data from an application perspective without a clear maybe research questions or a clear goal what to do with that, but learning in the meantime. And this project features more traditional setting. Juliana did a quick overview of the project yesterday, so I'm not going to go into it, but particularly in which particular tasks are we doing with the data in action, let's say. So we at the JADS were particularly concerned and particularly involved in these tasks. So developing a DevOps methodology for developing microservices and functional service applications, decomposing applications, and making correctness and defect prediction on the infrastructure code. So the infrastructure code is the one that is used to actually deploy automatically the application to the cloud or to a private cloud or whatever. So we actually did this data engineering in action approach for these tasks. Quickly, we are trying to develop a DevOps, DataOps methodology for developing these microservices applications. Also doing correctness and defect prediction. You can see here to detect anti-patterns, code smells, and evaluate the code based on quality metrics. So, in particular, we are concerned again with infrastructure code because I think that much work has been done on this for traditional, application code, standard programming code, but we are trying to tackle this newest idea of infrastructure code, so programmable infrastructure, like using Ansible or Puppet or Chef to automatically deploy an infrastructure. This kind of code can be subject to anti-patterns, code smells, errors, and we can measure them using quality metrics based on the actual data. So this is basically what I just said. We are concerned with this kind of languages, not traditional programming languages, to detect all these kind of problems, anti-patterns, code smells, so on and so forth, by a data-driven approach. What do I mean with this? Basically, we needed a big data set of scripts, of blueprints, of templates on those languages, so infrastructure code languages, and we went to GitHub to gather them. So with this small crawler, which was basically gathering information from GitHub repositories, basically trying to get as much as examples as possible of infrastructure code scripts, but focusing on good repositories. So repositories with a good amount of stars, of contributors, of commits. So no test repositories or classroom repositories, but real production repositories or open source relevant repositories. So we gather around, I don't know, a couple of thousands of repositories, which made for 30,000 scripts, more or less, roughly speaking, in Ansible scripts, Chef scripts, Puppet scripts, that we could actually try to measure their quality and detect their code smells and patterns and anti-patterns. So we got the data, and then now we are in the process of building the metrics detectors and the code smell detectors and patterns and anti-patterns detectors for infrastructure code. So by setting up our focus on these kind of repositories, we are more or less sure that the data we are getting is relevant, actually. We can use it. And we complemented this with a survey with practitioners. So we interviewed lots of people working on DevOps and different companies that told us basically which were the tools that they were using and which combinations of tools and which problems they were getting. So we got the data, we got the problems, and we can cross-check the detection of these problems in the actual infrastructure code scripts. So you can see here more or less the most used tools for DevOps. There are over the top, there's Ansible, there's Chef, there's Puppet, and there are also other more generic tools like Docker and Ansible and Vagrant for virtualization and containerization, but we are not going to focus on those ones right now, maybe later. So we kind of took this bottom-up approach, starting with the data and the metrics and the statistical analysis, and now we are trying to see what we can do actually with that, detecting and calculating metrics for data quality, for code quality on this kind of scripts. So I don't know if they have hard-coded passwords, if they have repetition, if they have circular dependencies, if they have too long or too short blueprints. All these indicators we can detect of bad quality or cold smells in infrastructure code. And with the ultimate goal of using this as a training set for a predictor in which we can just live when we are developing our infrastructure code scripts, detect or pop up to the developers the possible or potential problems and the solutions, so the refactorings that could be needed. Willem-Jan, I don't know if you want to take back in these ones with the roll ahead.
Yeah. So, so with this project, we learned a lot. I told you we have just started with this journey. We are adopting, let's say, the traditional approach throughout more the, let's say, the H2020 project. But what we want to do is get involved in more and more of these actual field experiments. But of course, we hit a lot of problems. I shared with you already a couple. Just to share other ones, is that what we assumed during the passport event is that we would have communication over phones. It didn't work. So we had to resort to other means of communicating with each other. The drones could only fly for 20 minutes because otherwise the batteries got overheated. There was other problems. We asked the drones to fly in a straight line outside. Well, you're not allowed to fly over the tents and the audience itself. You have to fly around the periphery of the passport premises. But of course, at the end of the day, this was not really good to do measurements. So you need a steady place for these cameras, even if you fly high. So this next time we'll use a stationary camera. Also, what we found out is that at the end of the day, the infrared camera worked best. I mean, these were all lessons learned. Right now we are conducting still some experiments, and it showed you already some results of one of our students on these trajectories that we followed. We also did do cluster analysis. We find out also outliers, strange behavior, zigzagging. I shared you about it. And also what we want to do is, of course, further study the idea of federated machine learning. So because part of the machine learning can take place in the drone, part of it can take place in the glasses, and part of it could take place in the cloud. So this is another spin-off project that we expect. Again, we didn't have any idea before we started on what the research, let's say, spin-offs would be, and now we're slowly shaping them and splitting up work in student projects. And what we're trying to do is raise the bar. So we're trying to be more efficient and more effective at the end of the day. And we will conduct more experiments, maybe at these festivals. And another idea that we have is to be involved in nudging. So one experiment you may have heard of is taking place at Startums Eindhoven, an experiment, a living lab, I should say, in Eindhoven, where they try to influence behavior through light. So it's a joint project by the Technical University and Philips Lighting. These are signifying. So we are thinking about similar experiments later on. I hope you guys have had a little bit of fun this morning. So we tried to come up with a presentation that at least would stimulate your thoughts a little bit. Would also show that doing science is a lot of fun, not only here, but also back home. I think that more or less wraps it up.
Okay, so thank you. Questions? You already had
you? Would you dare to do the same approach of running around with glasses and so on a heavy metal festival?
I was indeed very careful in selecting the festival, I need to be very honest. I knew this would be a quiet audience. But what, of course, we have agreed upon with the festival organ, we also have protocols for the students. So, for example, if the audience would ask, it's very complicated to do it. So, if the audience would ask, what are you doing here? Right here, we have protocols that you should follow. Also, of course, we try to have minimal impact on the people. And these days, I would use body cameras, for example. That's another experiment. We use micro drones and stuff like that. Because indeed, you will always have this big brother who's watching the phenomena. But in practice, none of our students were asked anything. So they were walking around at the entrance, no one asked. That was for me a surprise. You would think people are very concerned. Yeah.
My question is the following: would you say you just apply existing technology and combine them nicely
yes.
to a new thing, but you don't develop any new principles
No, the novelty is really in the combination of these technologies. For example, the triangulation.
Yeah. So you combine existing technology. That's what they also do.
Yeah.
Okay. Thank you.
But
We
when,
also-
when we discussed it, he said it in a much less nice way to me than to you.
No, it's true. I mean, I don't see our, indeed, let's say, added value in creating new machine learning technology. Honestly, we are not the experts. We are applying it and combining it with sources of data engineering.
But applying it in a certain domain, that's my experience, might lead to some refinements that are unique to that domain and that really improves the usability. And I would like to see that as a contribution, because that can help others in that domain or neighboring domains to skip that step in the future.
That's exactly what I meant in one of the first slides. We want to generalize over the domains. Yeah.
More questions? More questions? So let's thank the speakers again.